Yurtseras is planning to open a store in Mongolia's capital city of Ulaanbaatar to sell their domed yurt. The walls of this yurt are a right circular cylinder of height h and radius r meters, and the roof is a hemispherical cap of radius r meters, as shown in the diagram. So we've got this sort of circular barn sort of setup that we have to obviously going to do some differentiation on. So let's see what the first question says. Let the total volume of the domed yurt be V. Express V in terms of R and H. Alright, this is hopefully pretty straightforward. So we know our volume is equal to the volume of the cylinder part plus the volume of half a sphere. So for the volume of the cylinder, we should know that the volume of any prism that's not good. The volume of any prism is equal to the area of the base times the height. So in this case, and that's a cylinder, believe it or not, the area, the volume of a cylinder is going to be pi r squared. Pi r squared because that's the area of the base times by the height. Then we're going to have to add on half the volume of the sphere, and the volume of a sphere is 4/3 pi r cubed. If you're not sure why that is, I'll put a link in the description about why that is. It's to do with pyramids, and it's pretty straightforward proof if you want to have a look at it. But we've only got half a sphere, so we're going to times that by a half. So it's a half times 4/3 pi r cubed. Well, half times 4/3 is 4 on 6. 4 on 6 is the same thing as 2 on 3 pi r cubed. So it's plus 2/3 pi r cubed. Did I get that right? 4/6 is the same thing as 2/3. Yeah, that's right. Alright, so there you'd get your 1 mark there. Next, the total volume of the yurt will be 18 pi meters cubed. So this is an important piece of information. It's saying that we're keeping the volume of the yurt constant. So that means if the radius changes, the volume. That means since we're keeping the volume constant, that means if the radius changes, the height must change. So keep that in the back of your mind. Show that h equals 18. If my page would stop tripping out. Show that h equals 18 on r squared minus 2r on 3. Well, we know that the volume is 18 pi. So using the equation from above, we know the volume is 18 pi, and that must be equal to pi r squared h plus 2/3 pi r cubed. Now you can see the only things we have in this equation are r and h. There's no other variables, so that means that there's a relationship if we rearrange it for the relationship between h and r. Now we can subtract 2/3 pi r cubed from both sides. So it's 18 pi minus 2/3 pi r cubed is equal to pi r squared h. Pi r squared h, good. And then we can divide everything by pi r squared. So let's see if we can do that. So it's going to be 18 pi, and let's do it in two separate things. 18 pi divided by pi r squared. Now this is where people get confused because we've got a fraction and then we're dividing it by another fraction. The way I would do it to be super clear is write it like this. So it's minus 2 pi r cubed. 2 pi r cubed on 3. Then we're dividing by pi r squared, Well, that's the same thing. Dividing by pi r squared is the same thing as multiplying by 1 on pi r squared. Hopefully you can see that. And so, with that information, we can see that we're just multiplying fractions, and then this goes into the denominator. Pi r squared jumps into the denominator over here. So we'll do that. Pi r squared, all of this equals h. Moving h to the other side because we can. We'll swap things around. All right, the pi's cancel out, so we're left with 18 on r squared. Computer's very laggy. And then here we get the pi's cancelling out. So it's going to be minus 2 on 3. And we're going to have r cubed on r squared, so that's going to be 2r on top. And that is as required. So the tents are to be designed so the occupant can stand upright next to the wall. Assume that all Mongolians are at most 2 meters in height. That's a weird assumption. The values which are in part I may take lie in an interval between A and B. Find the endpoints A and B of this interval correct to 4 decimal places. All right, this is where it gets a bit trickier. If we go back and have a look at I, we can see that the height is related to the radius in this way. Now, I think the question's worded a bit unclearly, but what it's saying is the height of the yurt needs to be at least 2 meters high, because anyone that goes in needs to be able to stand upright, whatever that means, next to the wall. So we need to say that the height, so this function here needs to be greater than or equal to 2 meters. So the way we do that, if we have a quick look, so it's h equals 18 on r squared. So since h of r, because r is a function, h is a function of r, must be greater than or equal to 2. That places constraints on r. So we know what h of r is. We know h of r is 18 on r squared. R squared minus 2r on 3. And we know that that has to be greater than or equal to 2. So just to be super clear about what this is saying, it's saying for what values of r does this stuff on the left-hand side give us an answer that's greater than or equal to 2? Because we need a yurt that is at least 2 meters in height. And remember, this is h. And we need h to be greater than or equal to 2. So that's the inequality you need to set up. This is a calculated question, and if you look here in the corner, I've already sort of done it. But essentially what you're doing is you are solving h of r greater than or equal to 2 in respect for r, and we know that the radius can't be 0, because if the radius is 0, that means we have a volume. We have no volume. You can't have a yurt with a radius of 0, essentially. So it's not inclusive. It's not including 0. Okay, so if you chuck that in your calculator, you'll see that the calculator will spit out an answer for you, and it tells you that your r values to have so that your yurt is 2 meters or taller, your r values must be between 0, not including 0, and up to and including 2.26463. On your calculator, I don't think it will give you an answer like this straight away. It'll give you some wacky exact answer. Just make sure you press Control Enter to get to that answer. So yeah, that question's slightly more tricky. to get your head around, I think. All right, but yeah, that's the basic gist of it. Now, so your R values, yeah, so your answer is 0. Your R values have to be between 0 and less than or equal to 2.264, approximately. So the material used to make the sides of the yurt cost $3 per meter squared, but the material used for the dome ceiling cost $10 per meter squared. Find an expression for the total cost of the materials, C dollars, used in the yurt in terms of R. In terms of R only, okay? So as soon as we involve price, people usually get pretty confused. Think about this analogy. If you have some wall to paint, and let's say it's 1 meter by 1 meter, so it's 1 meter squared. So the wall is 1 meter squared, and let's say it costs $3 per meter squared to paint this wall. The paint costs that much. It's expensive paint, let's say. So how much would it cost for 2 meters squared? Well, that's pretty obvious. It's $6. What about 4 meters squared? Well, as you can notice, all we're doing is we're multiplying by the amount of square meters we have to find out how much it costs. So in this case here, it'll be 3 times 4, which is $12. Anyway, the point I'm trying to drive home is that when you have a cost per meter squared, what you're doing is to get the cost of how much, to work out how much it's going to cost, you have to multiply the cost per meter squared times the area of that thing. Okay, so now this part of the question is asking about the surface area of these things, because we're talking about the materials used to make the dome. So that means we're interested in the surface areas. So we need to know the surface area of a hemisphere. Okay, the surface area of a hemisphere is equal to, well, a surface area is a sphere. Let's do this in red. Surface area of a sphere is equal to 4 pi r squared. If you're not sure about that, Google it or take my word for it. The surface area of a sphere is 4 pi r squared, which means the surface area of a hemisphere is 2 pi r squared. Okay, good. Now, the next thing we need to know is the surface area of a curved part of the cylinder. What I mean by that, not a curved cylinder, what I mean by that is this part, the curvy part of the cylinder, the part that you hold onto if you're holding onto a can. So that is equal to, well, hopefully you know this now, but imagine you're walking along the surface of the circle as an ant. That distance you would have walked would be 2 pi r. So if we were to unfold our can or our cylinder, we would know that the distance up here would be 2 pi r, and this distance here is just our height of our cylinder, so that's h. So we know the surface area of a curved part of the cylinder is equal to 2 pi r times h. Alright, but can you see here that we have something in terms of h? We want everything in terms of r, like it says in the question. So we have to rewrite this, so it's 2 pi r times, well, the question said before that h in terms of r is 18. Let's get that out of the way. Is 18 on r squared. Good, minus 2r on 3. Good. Alright, so now we simply just need to know the cost. The cost of a hemisphere, as I said before, you just need to multiply it by the cost per meter squared. So the first one, so let's do the domed part first. The material used for the dome ceiling costs $10 per meter squared. Well, we've got 2 pi r squared meters squared of surface area for the dome part. So we just need to multiply that by 10. So it's 20 pi r squared. All right, the next one's a bit trickier. So it's the cost of the cylinder part. Okay, well it's just $3 times 2 pi r times 18 on r squared minus 2r on 3. All right, good. Now, what you need to do to work out the total cost, or a function for the total cost in terms of the radius, I should say, well, that's just equal to 20 pi r squared. Now, I don't want to stuff this up. Plus, all right, let's do this very carefully. 3 times, all right, let's multiply 2 pi r in. So that r is going to go with that r, so it's going to be 36 pi on r minus, this r is still here in this case, so it's 4 pi r squared on 3. Anyway, your calculator can do this. I don't know why I'm doing it. All right, now we multiply the 3 in. 36 times 3, I hope, is 36 times 2 is 72. 72 plus 30 is 102. Plus 6 is 108. Good. So it's 108 pi on r minus 4 pi r squared. Good, so that's our answer. We've got actually like terms here. You can see we've got 20 pi r squared minus 4 pi r squared. So if we just rearrange it slightly, it's 108 pi on r plus 16 pi r squared. Anyway, the important part of this question is to be able to recognize that you need to multiply the area, the surface area of the two different parts, and multiply that by the cost. And then you get a function, and I should have good notation here. You get a function for the cost, total cost, in terms of the radius, which is what you can see here is the answer. If you did it by a calculator throughout, you might get an answer that looks slightly different to this. The way you can check is set your answer equal to this to see if you're on the same page. If it equals this, that's fine. Sketch the graph of C over an appropriate domain on the axis below, showing any coordinates of the relevant features correct to 2 decimal places. You're not required to show the coordinates of any turning points. All right, I've seen this before. It looks something like that. We know that our radius goes from 0 to 2.26, I think we said. What did we say earlier? 2.264. All right, and I don't know what to get full marks here, I should write down the y value at this point. I don't know what that is because I haven't got a calculator, but I'm just going to write it as C. It's just going to be C of 2.264, isn't it? And I can leave you to work out what that is. Sketch the graph over an appropriate domain and explanation showing any coordinates of any relevant features correct to 2 decimal places. Oh yeah, we need to. Yeah, I think that's about all you need. There is an asymptote if you graph it. There's an asymptote at x equals 0 as well, so you might want to do that. Use calculus to find the exact value of r for which C is a minimum and the value of this cost. Express this minimum cost correct to the nearest cent. Okay, so our function is above there, so C of r is equal to 108 pi r. C of r. C of R is equal to 108 pi on R, is that right? Pi on R plus 16 pi R squared. Alright, what this question is essentially asking us is to find the value of this point here. The reason we want to know this point is because this is where we get the best value for money. We get the most radius for the minimum amount of cost, which is obviously how you want to be thinking about optimizing the cost effectiveness of your yurt. Use calculus to find the exact value of R. Yep, so using calculus means we have to do it using calculus. We can't just do it by graph tracing or whatever. C dash of R, I don't know what that is. You can put that in your calculator, find out what the derivative of that is. It doesn't, I don't think it'd be too tricky. There it is there, so it's minus 108 pi on R squared plus 32 pi R. Alright, then the reason we set it to 0 is because this is a turning point, which means the derivative at this point is 0. And what we mean by that is the gradient at this point is 0. It's dead flat there. So we can use this fact and say, alright, this must be equal to 0 at the minimum point, which is what we're trying to find. So if we say that this is equal to 0 and then solving for R, we get that R is equal to 3 on 2. If you put that in your calculator, so in your calculator you do solve C dash of R equals 0 in respect for R. With the right amount of brackets there, yep. Good, so that gives you 3 on 2. So we know this value here is 3 on 2. And we just need to know the other value at this point. Well, to find the other value at this point, all we need to do is substitute in the x value, which is 3 on 2, into the original equation. So you can see what we need to do now is do C of 3 on 2, because then that will tell us the cost for the minimum cost at this point. So C of 3 on 2, as you can see down here, is $339.29. Good. All right, so that's basically all of that. This extra line they've done here in the solution, I've just got the solutions because I didn't have a calculator to do all this. Yeah, all they've done is they've showed that it's a minimum point. With these sorts of functions, if you're not clear what they look like, you could be finding a maximum point, but we can see that clearly in the question asks for a minimum point. So they've just made the extra step of being super careful, which is advisable, I suppose, to make sure that what you're finding is a minimum point. So we can conclude that the cost of the yurt will be a minimum when the radius is 1.5. And when the radius is 1.5, the cost to build the yurt will be $339.29. So there you go.